Good morning, good afternoon, and good night, ladies and gentlemen. Okay, so today's video, we are going over factorizing, and I'm going to be recapping all of the factorizing methods you will need in your examinations. So, what is factorizing? So, factorizing is basically the verb to put a number or expression as a product of its factors. So, if I said 12 factorized would be 2 times 6. That's it. In terms of algebra, though, factorizing is the reverse of expanding. So we need to turn an expression into a product of factors. So here's a little example here. So expanding here, I'm getting rid of my bracket, but then factorizing, I'm telling it, no, you're going back in. You're going back in the bracket. So we're going to learn about 4 factorizing methods here. We're going to learn about highest common factor, grouping, difference of two squares, and quadratics / trinomials. So highest common factor. So what we do with the highest common factor is we find the highest common factor of an algebraic expression. We put the highest common factor outside of brackets. We divide each term by the highest common factor to find the factor inside the bracket. We write down the factors and then we check our solution. So well enough me saying it, we're going to do some more examples now. But anyway, first, what's the highest common factor? So you might recall from first year, highest common factors of 2 or more numbers or terms is the greatest factor which divides them both evenly. So for example, 12 is the highest common factor of 24 and 36, as in 12 is the biggest number that divides 24 and 36 evenly. So what we do with numbers, we can do with algebraic expressions as well. So I have a 4x squared and a 12x. So I need to find what is the biggest algebraic term that can divide both of them evenly. So to do that, I'm just going to write 4x squared. I'm just going to write that as 4 times x times x, because an x squared. So I have 2 x's there. And a 12x, which would be 12 times x. So first what I do is, for the highest common factor, I first find the highest common factor of the numerical components. So do they have anything in common? So 4 and 12. What's the highest common factor of 4 and 12? Well, it's actually just going to be 4. So that's my numerical components. Now I'm going to look at my algebraic components here. And what do they have in common? Well, they have one x in common. So I'm just going to write x there. So my highest common factor of 4x squared and 12x is 4x. And then using this information, we're going to start factorizing. So factorizing via highest common factor. So factorize fully each of these expressions, 10xy plus 15yz, right? So first of all, I need to find what 10xy and 15yz have in common, right? So I'm going to open my bracket here. So I need to write my highest common factor outside my bracket. So what do they have in common? Well, first I'm going to look at the numerical components. So 10 and 15, the highest common factor of 10 and 15 is in fact 5. So I'm going to put 5 outside my bracket. And then looking at the algebraic components, they have a y in common. So I'm going to take out a y outside as well. So I have a 5y outside of my bracket. And what I just do is I now divide each term here by 5y. So 10xy divided by 5y is going to give me 2x. And 15yz divided by 5y is going to give me plus 3z. And that's my answer there, fully factorized. 5y times 2x plus 3z. And to check if my answer is correct, all I need to do is I need to multiply it to bracket. That's it. If I multiply it to bracket, I can check my solution. Right, let's move on to the next one here. 16x squared minus 12x. Right, so I'm going to be doing highest common factor here. So let me have a look. Do they look like they have stuff in common? So first I'm going to look at my numerical components. So what 16 and 12, they have 4 in common. Highest common factor is 4. So I'm going to take out a 4 here. And then what algebraic terms they have in common? Well, they're going to have one x in common between them, because 16 has 2 x's, it has the x squared, and 12x has only the 1x. So they have 1x in common. So I'm just going to take out an x here. Then divide both terms by 4x. So 16x squared divided by 4x is just going to be 4x. And minus 12x divided by 4x is going to be minus 3. And there is my answer. 4x times 4x minus 3. And again, if I want to check that solution, I just need to multiply it out. Now, sometimes you can get highest common factor questions like this. Now, this one's a bit tricky. I'm going to explain why it's a bit tricky later because it looks like a different factorizing method. But I have 3 terms here. And you can use highest common factor up to as many terms that have common factors, you know. So I'm going to look at here. So look at my numerical components. 6, 3, 9. What do you have in common? Well, they have a 3 in common. So I'm going to put a 3 outside my bracket here. And then what algebra have in common? Well, so I'm going to rewrite this out. So I have 6a squared x. That is 6 times a times x. Sorry, that's a bit blurry. 3ax squared. Well, that's 3 times a times x times x. And then I have 9ax, which is 9 times a times x. So I look at my algebra. Well, they all have an a in common, and they all have one x in common. So I'm going to take out a ax, and now I'm dividing each term by 3ax. So 6a squared x divided by 3ax is 2a. 3ax squared divided by 3ax is just going to be an x. And then finally minus 9ax divided by 3ax is just going to be minus 3. And that is my solution there. Fully factorized. And again, if you want to check your answer, multiply it out. Right, so that was my first factorizing method. Don't worry, I haven't seen the last of it yet, because we're moving on to grouping. And grouping is basically highest common factor with extra steps, yeah? So what is grouping? So for grouping, when we have 4 terms, if I see an algebraic expression that has 4 terms, ding, 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 probably using grouping here, right? It's important to remember in your exam, like they're not going to tell you, which one to use. They're not telling you, like, use grouping for this one. No, that's not how it works. Normal Folio doesn't want that, yeah? So you need to recognize the patterns in order to which ones to use. So grouping, 4 terms. We need 4 terms for grouping. So what we do is first, so we group the terms into pairs with a common factor. We factorize each them pair separately. We make sure the factor inside the first and second brackets are the same. We take out then a new common factor. We write down the factors and check the solution. So again, well and good me just saying it. Let's put it in practice. So when we factorize an expression that has 4 terms, we remove the common factor from each pair of terms. So I need to make sure I have a pair of terms here that both have something in common. So I have an AP here minus AQ. Okay, they have an A in common, okay. Then I have a 2BP minus 2BQ. Okay, they have a 2B in common. So first I'm going to do my first bracket. So AP minus AQ, what do they have in common? They have an A in common. So I'm going to take out an A, divide both terms by A, so I'm going to be left with P minus Q. And then here, 2BQ minus 2BP minus 2BQ, they have a 2B in common. I'm going to take out a P minus Q. So that's my first step. Then my second step is, again, I'm using highest common factor again. Because between these 2 terms, what do they have in common? Well, they have a P minus Q in common, don't they? So what I do now is, I just take the P minus Q, bring it out here, and what I'm going to be left with, I'm going to be left with an A plus 2B. And that's my answer fully factorized. Right? So let's do another example here. So this example here. This is weird. Okay, so I need to break it up in my factor pairs. Okay, fab. Look at that. SX minus 2TY. They don't have anything in common. So in this case, if I notice my factor pairs don't have any, or my pairs don't have anything in common, I need to reorder my equation first. So I need to reorder my equation in order to get stuff together. So I'm going to group this SX and TX together, I think. For me, I'm going to group them together and see what happens. So I'm literally just rewriting the expression. So I have Sx plus Tx minus 2Ty minus 2Sy. I'm just rewriting it. So I'm not changing anything, I'm just rewriting it. You know, like how 2 times 3 is the same as 3 times 2. You know what I mean? Same thing, different shapes. Yeah. So now I'm going to look at my terms here. So my first pair of terms, my second pair of terms. Sx and Tx, what do they have in common? They have an x in common. And in the bracket, I'm going to have s plus t. Then here, I have minus 2ty minus 2sy. So, be careful here. I'm going to take out a plus 2y. What I'm going to be left with my bracket in here? I'm going to be left with a minus t minus s. Hold on. This bracket does not match that bracket. Did I do something wrong? No. So let's look at these brackets now for a second. What is different about them? Yeah, see? These, I feel like Dora the Explorer. Like, do you see where the problem is? Like, anyway. So what the problem is here, I have a minus t minus s. It's just this bracket, but each term here is multiplied by a negative number. So to rectify this, if I change the sign of what's outside the bracket, I can change the sign of what's in the bracket. So it'll be t plus s. And t plus s is the same as s plus t. Now I see, oh, I have an s plus t in common. So s plus t, then I have left over x minus 2y. And that's grouping donezo. Right, so that was an example of rearranging. Okay, a third factorizing method we have here is difference of two squares. So, an expression in the form a squared minus b squared is called difference of two squares. We can factorize an expression like this. So this is a key formula, yeah? A squared minus b squared equals a minus b times a plus b. Note that this formula is not in your formula and tables book. So, to factorize an expression in the form a squared minus b squared, follow these steps. First, remove any common factor outside the bracket. So, do highest common factor first if you can. Write each term as a perfect square. And then use the rule accordingly. So, example here, y squared minus 81. So, difference of two squares. What am I being told here? What do I need to look out for? So difference, i.e. subtraction. I need to see a subtraction of two. So I need two terms that are subtracting each other, squares. And these numbers have to be can be written as a squared number. So just a recap on squared numbers. So a squared number is a number that can be written as something squared. So 16 is a squared number because it's 4 squared. 25 is a squared number because it's 5 squared, etc., etc. Algebraic terms can also be squared. So for example, x squared is just x squared, you know. 4x squared is just 2x squared, right? So let's have a little looky look here. So y squared minus 81. So first of all, two terms, bing. I have a minus sign, boom. Both of them are squared numbers, bada boom, bada bing, right? So let me rewrite this now as squared numbers. So y squared is just the same as y squared. And 81 is the same as 9 squared. Now I have it in this form, I am going to use my formula. So remember, a squared minus b squared equals a plus b, a minus b. So this case, a equals y, b equals 9. So therefore, this factorized is just going to be y plus 9, y minus 9. And that is my solution. So, one more example here, x squared minus 25. X squared can be written as x squared. Minus 25 can be written as minus 5x all to be squared. So 5 to be squared. 25 can be written as 5 to be squared. So my formula, a squared minus b squared equals a plus b, a minus b. So a equals x, b equals 5. So subbing in my formula, it'd be x plus 5, x minus 5. Bada boom, bada bang. There you go. That's fully factorized. Now, as I was saying before, sometimes we can have solutions. Oh, this one's already done for us here. Forgot to block it out. So I have a coefficient and the variable are both square terms this time. So look here, 4y squared minus 25. So as I said, 4y squared can be written as 2y all to be squared because 2 squared is 4 and y squared is y squared. And minus 25 and 25 can be written as 5 squared. Remember my rule here. So open up my brackets, it'll be 2y plus 5, 2y minus 5. And that's it. Bada boom, bada bing. Done. Same here. I have 9x squared minus 16. Well, 9x squared, that can be written as 3x all to be squared. And 16 can be written as 4 squared. So open my brackets here. So a is equal to 3x. So that's a, that's b. So I have 3x plus 4, 3x minus 4. And that is my solution. Now finally, I can have an example where I need to do highest common factor first. So I'm looking at this one here, 3y squared minus 48x squared. Oh, hold on, wait a minute. Okay, I have two terms. Okay. There's a minus. Okay. I'm seeing some squared bits. I have a y squared and an x squared. And now the juices are flowing. I'm like, this might be a difference of two squares in disguise. And it is. So first, I need to do highest common factor. So what do you have in common? Well, they have a 3 in common. Yeah, because 48 divides into 3. Or 3 divides into 48. So take out a 3. Now I'm going to be left with y squared minus 16x squared. Then this is a difference of two squares. Right? So I need to do my difference of two squares. So rewrite this out to be 3 times y all to be squared minus 4x all to be squared. A, B, use my rule, so I have 3 times y plus 4x, y minus 4x. And that is my solution. Right. And that's it, fully factorized. Right. Now, our final method of factorizing is quadratics. So a trinomial, yeah? So a trinomial is a algebraic expression with 3 terms. And a quadratic trinomial is an expression with 3 terms in the form ax squared plus bx plus c. So this is called the general form. Yeah, this here, ax squared plus bx plus c. We just want it to look like that. So just for example here, 5x squared minus 3x plus 4. That looks like this. It looks like it, yeah? So I need a squared term, a normal term. Well, not normal term. A term to the power of 1. The term by itself, basically, and a constant term. And that qualifies it as a quadratic. And this is how we factorize it. So if the coefficient of my x squared is 1, we use this method. So we find two numbers that multiply to get to constant, but add to get to the coefficient of x, right? Then we open up two brackets like this, x bracket x. Then we place two correct factors numbers inside, keeping the signs. So for example, x squared plus 8x plus 15, two numbers that multiply to get 15 but add to get 8. So 15, I have 1 times 15. I have 3 times 5, and I think that's it. Well, 1 plus 15 is equal to 16, so that's not it. 3 plus 5 is equal to 8, so bada boom, bada bing. So I'm going to open up two brackets here. I'm going to have x plus 3 plus 5, and that's it, done. So two numbers that multiply to get the constant term, but add to get the coefficient of the middle term or just of the x term. Here, this one's a bit tricky because I have a minus here now. So 8, let's think, what multiplied to get 8 but add to get minus 6? Well, I have 1 times 8, that's not going to work. I have 2 times 4. Ooh, that doesn't work either because 2 plus 4 is 6. And I'm looking for minus 6. So we need to remember negative numbers exist, people, yeah? Negative numbers are numbers too, yeah? So I have minus 1 times minus 8. So minus 1 times minus 8 is 8. Then I also have minus 2 times minus 4. That's the one I'm going to be using here. Because minus 2 times minus 4 is positive 8. But minus 2 minus 4 is negative 6. So open my brackets. Bing, bing, bong, bong. X, minus 2, minus 4. And that's it. Bada boom, bada bing. Again, you can multiply out your answers to check. So, again, if I have no number in front of my x squared, right, I'm using quotation marks because technically it's a 1, but if I have no visible number in front of my x squared, you use this method. Then if I do have a number in front of my x squared, I'm going to be using the guide number method. So to factorize a quadratic trinomial using the guide number method, follow these steps. So first of all, remove any common factors if possible. Yeah, okay. Find the guide number by multiplying the coefficient of x squared by the constant term. Okay. Find the only pair factors of the guide number which add to get the coefficient of the x term. So I'm doing what I did before. It's just one extra step. And I'm going to break up the x squared term into two separate x terms where these factors are coefficients, and then use the grouping method to find the factors. So I'm going to be using grouping in this as well. So again, handy dandy me just saying it. Let's do it, right? So 4x squared minus 12x plus 5. So first I need to find my guide number. So my guide number is equal to 20 because it'd be 4 times 5, yeah? So it'd be 4 times 5, which is equal to 20. Next step, I need to find two numbers that multiply to get 20, but add to get minus 12, right? To save you the heartache here, it's going to be minus 10 and minus 2, okay? Because minus 10 times minus 2 is plus 20. Minus 10 minus 2 is going to be minus 12. Now I rewrite this as 4x squared minus 2x minus 10x plus 5. I rewrite that, yeah? Because minus 12x is just the same as minus 2x minus 10x. It's the same thing. I just split it up. It's like how 5 is the same as 2 plus 3. Same thing, right? Now that that's done, I use grouping. So I'm going to look at my first two terms here. My second pair here. What do they have in common here? Well, they have a 2x in common. And in my bracket, I'm going to have 2x minus 1. Here, what do they have in common? They have a 5 in common. But look, if I take out positive 5, I'm going to be left with minus 2x plus 1. Again, so close. I have minus 2x plus 1, 2x minus 1. I need to change the sign. And in order to change the sign in the bracket, I need to change the sign of the number outside the bracket. So if I take out a minus 5 instead, I'm going to be left with 2x minus 1. And then finally, 2x minus 1. Both have that in common. Take out a 2x minus 1. And I'm going to be left with 2x minus 5 in my other bracket. And that's us done there for the guide number method. I'm going to do one more example of the guide number method now. So 6x squared plus 11x minus 10. So first step, find the guide number. So it'll be 6 times minus 10, which is equal to negative 60. Then find two factors that multiply to get minus 60 but add to get 11, or the middle term here. Oh, that's hard. Wait a minute. Ooh, am I gonna have to think about it? No, I don't have to think about it. Right. 60. So I have. So you just have to list them all out if you don't know it. But I'm just gonna save us the heartache here. Minus 60 can be written as 15 times minus 4, and plus 11 is equal to 15 minus 4. So now do that. Now you found my factors. I need to rewrite my initial expression. Let's see if I can make that bigger. There you go. Rewrite my initial expression. So I have 6x squared plus 15x minus 4x minus 10. First pair, second pair. What do you have in common here? Do you have a 3x in common? And so I'm going to be left in the bracket here. 2x plus 5. Here, what do you have in common? I'm going to factor out a minus 2 here. Then I'm going to be left with 2x plus 5. Finally, again, I'm going to factor out now my 2x plus 5. And I'm going to be left with 3x minus 2. And that's that trinomial or quadratic fully factorized using the guide number method. Then finally, the last thing here, simplifying algebraic fractions via factorizing. So in order to simplify algebraic fractions, we need to first complete any calculations required in the question, 2, factorize fully the numerator and denominator, and step 3, cancel out common factors and simplify further if required, right? So what do we mean by this? So let's just recall back on how we simplify fractions in general. So I have a 5, I won't do that one. I have an 8 over 10. How do I simplify a fraction? Well, I find the highest common factor of the 8 and the 10 and divide both of them by it. So here, what do you have in common? Do you have a 2 in common? So in the top, I have 2 times 4. On the bottom, I have 2 times 5. So I factorize the top, factorize the bottom. I'm cancelling out the terms, the factors they have in common. They have a 2 in common here. So I'm then just going to be left with 4 over 5. That's it. And that's how it works as well with algebraic fractions. So, for example here, I have 6x plus 12 all over 10x plus 20. So first step, complete any required calculations. I don't have any. Fab. Factorize the numerator and denominator. These are going to look like highest common factor. So I'm going to factorize the top. I'm going to take out a 6. I'm going to have x plus 2. Then on the bottom, I'm going to take out a 10. I'm going to be left with x plus 2. Now cancel out any common terms they have. So I have 6x plus 2 and 10x plus 2. Cancel out any common terms they have. Well, they have an x plus 2 in common. So cancel that out. So I'm going to be left with 6 over 10. Which again, this can be simplified even further then to 3 over 5. Right. So here's another one. Complete any calculations required in the question. So I have 2 quadratics. I have a quadratic on the top, quadratic on the bottom. That's a nasty one. So first step, complete any calculations required. Don't have any. Fab. Step 2, factorize the numerator and denominator. So I know for a fact on the top here and on the bottom. Okay. So I'm going to have here 2 numbers that multiply to get minus 10 but add to get minus 3. So that's going to be a 5 and a minus 2. So x plus 5, x minus 2. Then at the bottom here, 2 numbers that multiply to get minus 35 but add to get 2. That is going to be an x plus 7. Did I do something wrong here? Oh, sorry. Top one here. See, I make mistakes as well, guys. Sorry, it's going to be a minus 5 and a plus 2. Sorry about that. Just testing you guys. Then the bottom one here, I'm going to have a x minus 5 and an x plus 7. Then I just cancel out any common terms. So I have an x minus 5 in common in both. Therefore, my final answer is going to be x plus 2 all over x plus 7. And that is my final answer there. Right, and that is how to factorize a algebraic fraction. Right. Oh my god, 30 minutes. Right, okay. Yeah. So probably zoom through that. Hope it helped. If this did not record correctly, I'm gonna scream. Anyway. Yeah, anyway. Good luck. See you later, alligators. Peace.